Okay, today we're looking at our very final special segment within triangles, and it is the altitude of the triangle, also known as the height of the triangle. Altitudes, very simply, so this should probably be another flashcard for you. The altitude in a triangle goes from the vertex, and it is perpendicular to opposite side. Or an extension of the opposite side. I'll show you that in a second, why that's important. So very simply, I go from an altitude starts at a vertex, just like a median, just like an angle bisector, but this time, whoops, meant to draw. But this time, it's perpendicular. So it's forming a right angle down here. That's not the midpoint of the side it's intersecting. This is not a perpendicular bisector, it's just perpendicular to the side. Sometimes it'll be a perpendicular bisector, it could be occasionally, but usually it's not. And again, all three sides have altitudes. And all three altitudes come together at a common point, a point of concurrency. The point of concurrency for all three altitudes, right there, is called the orthocenter. Now, we had the circumcenter, circum meaning around, and the circle went around the triangle, that made sense. We had the in-center, which in means in, and the circle was inside the triangle. Ortho is an interesting prefix. The ortho center, where do we get that word ortho? What does that mean? Orthodontist. A lot of you have seen an orthodontist. Dontist means teeth, work of teeth. What does ortho mean? Ortho is a prefix meaning straight. And so the name here really doesn't make a whole lot of sense. It's the straight center. What does that mean? I'm really not sure. After 28 years of teaching geometry, I still am really not sure why it's called the orthocenter other than the fact that it is. There's not a lot of interesting stuff about the orthocenter except that it exists. It doesn't make circles. It's not a balance point. It really doesn't break things up proportionally. The orthocenter is kind of boring. Yet it exists, and we want to know that it exists and that it works. So, this is the definition. There is not a theorem associated with this. There's no formulas associated with this. It just exists. It is the orthocenter. It is where all three meet. Now, I said an altitude is perpendicular to a side or a side extended. What did I mean by that? Well, in the case of an obtuse triangle, whoops, undo that. Let's go back to a solid line. Here we go. In the case of an obtuse triangle of some sort, I'm going to make it so it's not isosceles or anything special like that. I can draw in this altitude fairly easily, and again, I'm guessing. But the other two altitudes are a little bit tricky, because if I want to go from this vertex to the opposite side, from this vertex, whoops, over here, let me use a highlighter, from this vertex to the opposite side, I cannot draw inside the triangle and get anything that even resembles a perpendicular line. In fact, the only way, can do that, Mark? The only way I can get a perpendicular line, so I'm going to extend this perpendicular line, by the way, make it nice and long. I'll extend it this way, too. The only way I can get a perpendicular line is to do an extension of my side. And then drop it down so it's perpendicular. And what you'll notice now, as I've had to extend my page quite a bit, is that in order to get these to intersect, I'm nowhere near, there we go, nowhere near the inside of my triangle. So I've got a right angle here, I've got a right angle here, and if I did a third one, I'd have to do an extension of this side. And when I did that, there's a right angle there. And of course, I'm estimating. My right angles aren't perfect, but we'll indicate it. All right. So there's my orthocenter, way, way, way outside the triangle. Because altitudes sometimes are not with the sides of the triangle, but extensions of sides. It's in order so I can get that right angle. So just something to keep in mind as we're doing this. I think I can probably come up with a slightly better approximation here because it's pretty easy to get that as perpendicular. So I'm thinking that this line is off a bit in order to be perpendicular. There we go. There we go. That's a little bit better estimation of my orthocenter, I think. I've got a little bit better right angles that time. So anyway, altitudes are not always inside the triangle. Altitudes sometimes intersect an extension of the opposite side. I want you to see an example of that. All right, find the coordinates of the orthocenter. A lot of what we're going to be doing here is working in the coordinate plane, which takes us back to what we were doing before, finding linear equations, working in the coordinate plane, that whole sort of thing. Obviously here, since we're dealing with perpendicular lines, we're going to have to be finding some slopes. But in order to find the equation of a line, it's really not that bad because all I need is a point and a slope of the line, and that shouldn't be too tough to find. So let's just take a look here. X is at -5, -1. So 1, 2, 3, 4, 5, -1, right about there. There's X. Y is at -2, 4. And Z is at 3, -1. Now, I've got some neat stuff going on here. I'm very fortunate to have a truly horizontal side. Finding a perpendicular is going to be really easy for that. Okay? Finding the first altitude is going to be super duper simple because Y here is at -2, 4. Okay? I know that that altitude has to come through here and be perpendicular to this side. Well, since XZ is a horizontal side, that altitude must be vertical. And the equation of that line is very easy to find. The equation of that line is simply X equals -2. I love finding the equations of horizontal and vertical lines. It requires very, very little work. Horizontal lines are always Y equals. For example, the line here is Y equals -1 for XZ. And vertical lines are always X equals -2. That's a simple vertical line. I do need to find, however, a second altitude so I can find where the orthocenter is. So at least I've got one line. I just need to find the other line. So I need to pick. Do I want to take the altitude from Z or the altitude from X? It really doesn't matter which one you choose. One might be easier, one might be slightly easier, one might be slightly harder, but it's basically you got to make a choice here. There's not a wrong choice. Let's take the altitude from, I don't know, let's take the altitude from, I think they're going to be about equally as hard. Take the altitude from X. So let's try to find that altitude. In order to find that altitude, I know it has to come from here and form a right angle. I don't know where this point of intersection is going to be. I really don't care where that point of intersection is. I just need the equation of that line. In order to find the equation of that blue line I just wrote in, I need two things. I need a point on that line, which I already have at X. I need the slope of that line. I don't know the slope of that line, but I do know the slope of a perpendicular line, or I can calculate it. I can calculate the slope of YZ. Once I have that slope, I can find the slope of the perpendicular line. So, little indirect, little puzzle solving, but the slope of YZ is going to be change in Y, 4 minus negative 1, over, which would be plus, over change in X, negative 2 minus 3. Or 5 over negative 5, which is negative 1. Fantastic. That actually works out really nice as a slope. The slope is negative 1. So the perpendicular slope for the altitude has to be the negative reciprocal of negative 1, which is positive 1. Now that I have that, I can write the equation of my line. Y minus the y coordinate. Again, I'm using the point X here as my point. So y minus negative 1, so y plus 1, equals slope 1, x minus the x coordinate, negative 5, which is plus 5. So y plus 1 equals x plus 5, distributing the 1, or y equals x plus 4. That's the equation of this, that is the equation of that altitude. Now I need to know where these two lines intersect. Well, my first line is x equals 2, so I know an x value, don't I? So y equals 2 plus 4, which is 6. Okay? Y equals 2 plus 4, which is 6. So my point of intersection, something's off here, because 2, 6 doesn't make sense to me. 2, 6 is up too high. What did I do here? The slope was negative 1. The point is negative. Oh! Do you see my mistake? I do. Haven't made a lot of mistakes in podcasts this year, but let's take a look at this. I plotted my point in the wrong spot, didn't I? Or did I? Negative 5 minus 3. Let's see what this is. Try this again. Y plus 1 equals 1x plus 5. Oh, x is negative 2. That's where I see my mistake now. Yep. So y does equal x plus 4. So y equals negative 2 plus 4. There's my mistake. I dropped my negative sign. So y equals 2. So negative 2, x equals negative 2, y equals negative 2. Negative 2 is my point of intersection. It's about where I had it. And I found the location exactly of my orthocenter. So again, the orthocenter here, we're doing a lot of work in the coordinate plane. We're finding equations of lines, finding where they intersect. It's a little bit of work. Careful not to drop a negative sign. I sure did. But also, it was pretty obvious when I came up with a mistake. When I had negative 2, 6, I knew my point of intersection wasn't way up outside the triangle somewhere. I knew it had to be somewhere on the inside given the drawing that I had. So I just reworked and checked it and found my error pretty quickly. All right, tell whether the orthocenter of the triangle with the given vertices is inside, on, or outside the triangle, then find the coordinates of it. Inside, outside, or on. How can I tell the difference? Well, if the triangle is acute, it's going to be inside. If it's right, it's going to be on. If it's obtuse, it's going to be outside. Okay? So inside would be acute. On would be a right triangle. Outside, it would have to be obtuse. So when I graph my triangle, I'm at 0, 3 for A, 0, negative 2 for B. Let's move that A. 0, negative 2 for B. Sorry. And 6, negative 3 for C. So, again, I'm drawing my letters in poor spots. A, B. C is at 6, negative 3, so 1, 2, 3, 4, 5, 6, negative 3. There's my triangle. I need to find the orthocenter. Clearly, it's an obtuse triangle, so we are going to be outside. Again, I need to find 2 of the altitudes. Now, a little tricky, but not too bad. Let's find the altitude from C, because this is a vertical side. So the altitude from C has to be horizontal. And the equation of that line is simply y equals -3. So that makes my life a little bit easier. Next, I need to find the altitude of, or the equation of one of the other altitudes. The altitude from B to AC, or the altitude from A to BC. I'm going to go find the altitude from B, so I'm going to use B as my point. I'm going to try to find this altitude. Now, I'm kind of guessing right away that my point of intersection here is going to be about -1, -3. That's what it just looks like from a sketch point for me. It might be exactly, it might not be, but let's find out. I know my y-coordinate has to be -3. Looks like my x-coordinate is going to be about -1. But to do that, I'm going to have to first find the slope of AC. The slope of AC is going to be change in y, 3 minus -3, over change in x, 0 minus 6, which is 1. I'm sorry, -1. Let's get that right. Boy, I'm having negative sign issues today, aren't I? So the perpendicular slope is +1. That's nice again. How nice is that? And so the equation of that line passing through point B, using B as my point, is y minus -2, so y plus 2 equals slope x minus 0, or y equals x minus 2 when it's all said and done. Well, I got to find the point of intersection now. I know y equals -3. -3 equals x minus 2, so x equals -1. And sure enough, my point of intersection, x equals -1, y equals -3, gives me the point of -1, -3. There's my orthocenter. It's a process. And again, to break it down in the coordinate plane, what do? We find, we start by picking a point. So we pick a point for the altitude. Pick one vertex. That's my point. Find the slope of opposite side. Then we take the negative reciprocal of that slope for a perpendicular line. Use point slope to find the linear equation. If necessary, repeat that for a second line, find where the two lines intersect. So, yep, lots of algebra. Lots and lots of algebra. But lots of opportunity to practice in class, lots of opportunity to practice outside of class. Please take advantage of all those opportunities, and we'll see you in class.